Hello, and welcome to this next level of finding a solution with substitution. Instead of plugging in or substituting a numerical term, a number, like in the last video, this would have, right here, would have just said 4. Now we have a variable term. Now we have 4x. It's going to be the same, but we don't have half of our answer anymore. We don't have x or y. We've got to work a little bit for it. It's not going to be that much, and I know you can do it. So we're going to substitute still. We're going to take, here we got y equals 4x in our first example. And we are going to put that 4x into our other equation for where y is. So I'm going to just replace this y. Everything else is going to stay the same. But the y is going to become 4x now. And now, if I look in this equation, I can solve it. Before I had a y and x in it. I can't solve for a variable. Now with just x's, I can figure out what x is. So I'm going to treat this like any other equation and get all my variables on one side by doing the opposite. I got a positive 2x here. I'm going to subtract 2x to both sides. These are going to go away. That's the 0x's. 4 minus 2x is 2x. Still got a positive 12 hanging out over here. Now I'm going to get rid of this multiplying with dividing. And get my x is equal to 6. So now I've got half my answer. And once you do have half of your answer, it's going to be like all of those other questions from before. You got to plug that x back in to get y. Now the choice here is you could plug into this one or this one. It doesn't matter. You're going to get the same answer. And in fact, I'll show you both. Here, if we plug in that x and make it into a 6, we're going to get 24. And here, if we plug in that x and make it a 6, we're going to get 24. So no matter what, we're going to get 6, 24 as our answer. And horrible line there, Chin, but you can do better. Boom, 624. Look at that big bracket. Okay. So let's take a step back and think about what we did. We took a term with a variable now and changed it from in the other line in the other equation, so that we could have just one variable in the equation, and then we balanced it, got all our variables on one side, all our numbers on the other. That gave us 1/2 of our solution, because we know our solution is a point which has an x and a y. Plug it back in, get that other term. Alright, boom. Let's move into the second example. Here we've got x is equal to negative 3y. So I'm going to take that negative 3y, that is equal to x. So I don't want to put it into the y like last time. No. Make sure you know what we're plugging it into. It is equal to x. So we're plugging it into x. So I still have my y. I still have my equals. I still have my 5, but instead of x now, what goes in there? That's right, we got negative 3y. On the outside, yeah, we still have that 32. We're going to multiply just like we would in any other situation here and get negative 15y. Oopsie doopsie, I wrote the 5 again. So we're going to multiply out 5 times negative 3. Opposite signs in multiplying always negative. Negative 15y plus 32. And I'm solving for y, so that means I got to get all the y's on one side. My numbers are already on the right, which means I'm going to get my variables on the left by doing the opposite of a 15y, negative 15y to both sides, which is positive 15y. I want to add it to my like term, cancel out, get a nice 16y here, a nice 32, which comes down normally, and then I'm going to divide out because my 16 is multiplying with my y. So the opposite of that, the undoing of that, is dividing. 32 divided by 16 gives me y equals 2. And let's not stop there, because we're going to remember that that 2 is just half of our answer, it's just our y part. But to get our x, this looks pretty easy. We're just going to plug it in. We're going to plug that 2 in to this y here. Negative 3 times 2, opposite signs when multiplying again, always negative. Negative 6. So if I went a little fast, maybe play the video at 7.75 speed, or talk to me. We'll go over some things and stuff and things and stuff.